black hole is just a specific type of a solution to Einstein's equation. It is just a specific type of relationship between space-time points in the equation for the distance. So where is the black hole actually contained here? There are two terms which actually mathematically you can see act in a strange manner. There are 2 points which behave in a strange manner. So one point is if you take radius to be equal to 2 gm. So when you put radius equal to 2 gm, then this is just equal to 1. So you have 1 minus 1, and that is 0. So the whole equation loses its sense. It diverges, it blows up. So there is something strange going on here. When you go to this radius, things blow up. When you are outside of this radius, everything is fine. But when you step at that, you have 1 over 0 and blowing up of the whole thing. So that's a strange thing. That's a strange point. And the second one is, of course, when you have r equal to 0. So when you have r equal to 0, you again have something finite divided by 0. So that's the second strange. So, and then the question was, what is the nature of these points? Because we said this actually is a solution of Einstein's equation. That means if we have some problem, like we have a star, and we can say around that star we have just vacuum, and that star is just completely nice and symmetrical and spherical, we have this as a solution. So what's the meaning of those points? Are they actually corresponding to something physical or not? So after a huge debate and a series of different investigations, the conclusion that was reached, and which can be shown with some quite more sophisticated mathematics, is that this first point, the r equals to gm, where this whole thing blows up, actually corresponds to something which is called a horizon. So a horizon is a point which is nothing special for the observer who crosses the horizon. He cannot observe any special effect happening there at the horizon. But the one who is staying outside and watching how somebody is entering the horizon will never be able to get any kind of information from him. So this horizon, the point where this equation acts strangely, is actually the point where you can enter, but you cannot get out of it. So it has such structure of space-time that things can go into the horizon but cannot go outside of the horizon. And that is actually then the edge of the black hole. So even the light, one can make this mathematical analysis and calculate how does light behaves when it crosses the horizon. Then the solution is that it just stays trapped there. So like light, then everything else cannot escape this region. For this very reason, the whole thing got the name of a black hole. So you see that it is actually hidden in here, in this divergence of this term, at this point where this term blows up. That is the edge of the black hole. And the second point which blows up, r equals 0, is actually the point which just remains as the central singularity of the black hole. It is the point where it seems, in general theory of relativity at least, the space and time together would get broken. So this is all actually what is essentially there in the idea of the black hole. You take an equation which combines the curvature of space-time and the distribution of matter-energy. You specialize in the case where this distribution is zero, so in vacuum, and you search for the solutions which are spherically symmetric, and then actually you get a solution, and it's a unique solution, the only kind of solution in general relativity, of this form. And then you observe that this solution has as its part a strange region. A region where you can go into it, but you cannot come out back. And this whole structure of space-time is just called the black hole. So that is all. So, I mean, the black hole is, of course, not some very exotic monster which goes around and eats things, or which has any physically surprising behavior apart from those two, as predicted by general relativity. So it's just a space-time structure. Just as we are living in one specific space-time structure in our usual life, so the space-time can have different shape. And one specific shape is that which has this horizon that you cannot escape. So it behaves in the same way as any other gravitational object, as any other gravitational effect would, but of course it has this special type of a structure. Of course it is not possible to go through all the details and really understand everything what I said just based on a very short lecture. So the idea of this lecture was to give some basic insights and basic concepts and mathematical descriptions which are used in answering the question, what is actually black hole? Because most of the discussions related to it, which are going on in the non-professional community, go in various stories and descriptions of particular properties and scenarios, but do not answer what it really is and how do we know that it exists, why do we think that it exists, how do we come to this idea at all. So the basic idea was to show the main steps. How does this idea of black hole intellectually shows up? How do you theoretically come up to that idea? So if you would like to go in detail and understand all of those things, then you just need to contact us and we'll be glad to help you.